I've got 17, but we have, actually let me do attendance first. Alright, so let's see. Is Friday the 7th? Anyone know? Yes. Okay, thank you. 14. Peyton, do you not have a phone? Oh,
man, look, you jump in our Abby room.
hold on.
Can I read
We're missing AJ.
Look,
Good morning.
Can I
Yes, you need. Be quick.
Hi, Miss
Number 19.
We missed you.
Huh? I did tell you good morning. I said good morning and I very quickly showed concern about your mom. And 22. Galatians. That one was present. That one isn't connected yet.
State playoff
Alright, I got 21 of us. Hey, 4 of us have not actually submitted yet. Make sure you submit. Don't just leave it there. Alright, I'm going to do attendance, and after I get attendance in, we are starting.
Is that where it was?
Yes.
Thank you. Alright, so we're going to stop the poll, going to look at this. So first off, what is the number I? Got a couple of us said I is not a number. Does anyone want to explain that, or does anyone want to refute that statement?
I is a
Peyton?
That's wrong because I is a number. You just can't really put it. It is a number.
Okay. Can anyone add any more onto that? That it is a number, but you can't really something with
It's
it.
literally called number I.
It's right, but I mean I may be misleading you there. Okay, so
It's imaginary.
okay, remember that's one of the things we talked about. It is not what kind of number? A real number. The graphing and the numbers you are used to are known as the real numbers, but we ran into an issue that we got a number squared is equal to -1. And originally mathematicians said that's not possible, and so they named real numbers and then they named the imaginary numbers. But we discovered, okay, there does have to be a number. Like we keep running into this idea when solving quadratics and other polynomials. And so we said I is what? What answer up here?
Square root of -1.
Square root of -1. And we know that, or the reason we figured that out is because we defined I squared as what?
Don't remember.
1 squared? -1 squared?
We have notes, we have a textbook that we're going to be using today. I squared is -1. Guys, y'all are going to be using that book. We should have used it for help on the bell ringer. We've got to use our resources, but we want to know, or we should know, that we defined, or mathematicians defined, the number I such that I squared is -1. Well, if a number squared is equal to 4, what is that number? That number could be 2 or it could be -2. We're going to focus on just that 2, right? If a number squared is 25, then what is that number? 5. So if a number squared is -1, then that number is square root of -1, right? That's how we're getting I. And so the name for that, I equals square root of -1, is known as the pure imaginary number. We're going to talk about that in a second. But be careful, because I cannot tell you how many students I see tell me that I is -1. I is not -1. What I squared is negative 1. I is the square root of negative 1. Be careful about that. Okay? Questions, comments, concerns about that detail before we continue? Seems like we're okay. Not stressing it too much. So, here's a couple of things that I want to point out before we start today's lesson. If I have the square root of negative 4, we need to know how to simplify this square root. A little bit at least.
2.
Not a ton. Say again.
2.
Okay? Everyone agree 2?
No.
I mean, you could divide it by 4 to be negative 1. Negative 4 divided by 4.
Okay.
2i?
So I, 2i, 2, maybe some combination of those or thinking about it. So why are we thinking I? Where's that idea coming from?
I can't be an exponent, can it? Like, not an exponent, like, a variable?
Well, I is not a variable. I is a number, the square root of negative 1, right? And so we're talking about I here, which I is the square root of negative 1. Do we have the square root of a negative?
Yeah.
Yeah.
So negative 2i.
Close, but be careful about that.
2.
So here's what I would do if I were you, and we'll practice some of this later. If I want to deal with the number I need the square root of negative 1, right? Yes? Okay. So can I rewrite negative 4 so that it's negative 1 times something?
Negative 1 times 4.
Negative 1 times 4. And that's exactly what you would want to do. And so square roots or radicals have a property that you can split up that radical. Notice how we're multiplying. So this would just be the square root of negative 1 times the square root of 4. That's it. Now I can simplify it. What is the square root of 4?
2.
2. And what's the square root of negative 1?
I.
I. If you see a square root of a negative, you know you're going to get what number at the end?
I.
You have to get an I there. If you get the square root of a negative, there is going to be an I. And the easiest way is to split up those factors. And then you can see that. In a similar way, square root of negative 5. Now, can I take the square root of 5 and get a nice pretty number? No, it's not a perfect square. But because I'm taking the square root of a negative, I know I'm going to get what number? I. So, the same thing is going to happen here. Square root of negative 1 times 5 is equal to?
Square root of negative 1 times square root of 5.
Notice I'm just going to separate it so I get a square root of a negative and a number. And then when I get a single square root like that, I can rewrite it as 2 square roots being multiplied. I cannot take the square root of 5 and get an integer. Does anyone remember what kind of number it'll be?
Irrational.
Irrational. Remember, when you take the square root of a non-perfect square, that decimal is never going to stop. It's never going to repeat. And so the square root of negative 1 is I, and then the square root of 5. And that's where I would stop. We'll get some practice with this today so that you don't have to have mastered it right now. But does that basics make sense? Or what questions, I guess, do you have? Say again. We're going to get practice with it. I'm going to leave it on the board so that when we get to stuff like this later, you have that as notes. Does that make sense? Okay. All right. Did you have a question, Kyle? You're just stretching.
It's not really.
Okay. All right. So I'm going to play from current slide. I'm going to use presenter view. Okay. So here's where we're getting started with today. So we're going to wrap up lesson 6, I want to believe imaginary and complex numbers. We already did that number I recap, so I'm going to skip to activity 6.5. Please note, we are skipping activity 6.2 through 6.4. That's a lot of adding, subtracting, multiplying with imaginary numbers. It is good, but we are on a time crunch. At least I always feel like I'm on a time crunch. This right here, this lesson 6, is going to be our review for the day. So if you remember, we talked about it last week that we're going to let the quadratics be our 9 weeks exam. for the most part. And then that gives you all time to come into tutoring. I emailed you and your parents last night about what the tutoring situation will be for this week because we have a faculty meeting after school and I can't make this afternoon. Yes, ma'am?
Did you erase the tutoring session?
Yeah, I put it back up there. Well, I didn't erase it. I'll let whoever was working on there erase it. But I'll put it maybe up there in the top right or up here in the top left during planning today. But I emailed everybody what the tutoring will be for this week. So whatever email address I have for you, that's where I emailed it. So please remember, I want you to be successful. Take advantage of your resources to master the things that you're struggling with. If you can't make it to tutoring, tutoring is the best option for learning the things that you've been struggling with. But I also have other options. We will go over the understanding check from Friday tomorrow, and that'll be our review tomorrow. But that's reviewing mostly quadratics. You will have, you do need to review linear, exponential, and quadratic. You do need to review, what's the other thing? Oh, the forms of quadratic equations as well. Basically the three major understanding checks we've had, and a little bit on the statistics side. I will have a list of concepts you should know from the statistics stuff for the 9 weeks exam, and I'll give that to you tomorrow. Yes, Madison?
Will you make like a review sheet or anything, or do you just want us to use those understanding checks? Because a review sheet would be nice. A review sheet would be really nice. I mean, really.
Yeah.
Okay, but that's what the understanding checks are.
Yeah,
It's
but-
every concept that'll be on the test.
I get where you're at. I get where you're coming from.
Yeah. So I will give you an abbreviated list of concepts for the statistics side of things, but everything that's on the understanding checks will be on the test.
I'm missing one. You still didn't give it to me.
You're right. I have a note about it and I keep forgetting.
If
I'm
we
gonna write
lost
that here.
those, could you make a copy?
Do you remember which understanding check it was? I'll just print those out, I guess.
Yeah, it's not.
It wasn't the one. It was the one with the pink. With the pink. Just do both of them.
Okay. All right. Yes, Tori.
And like, if you come into tutoring, are you just going over what we learned that week?
No. If you come into tutoring, I'm answering whatever questions you have.
Okay.
Tutoring is for you to ask questions, and I can create problems, I can explain things again, stuff like that.
Okay.
Tutoring is based on what your needs are. Yes, Peyton.
Can you please repeat the stuff that we're gonna do for the exam again?
I am going to print out a list of abbreviated concepts, and I'll give that to you tomorrow, okay? I will say I created some modules in Mathia that are going to help you review some of the statistics things, the normal distributions like the empirical rule and z-scores and all that stuff. Yes, ma'am?
Did we have something about you do this weekend?
No. So, before tomorrow, you need to have checked that you can access Clever and go to Carnegie Learning, because we will make sure that everyone sees what it looks like that you should be looking at. All right, we gotta get started though. Hopefully, no more questions. We comfortable with what's the expectations for this week?
What?
I'll take it that you're comfortable with it. All right, so we're here on lesson 6. We're on the imaginary numbers, the number I. And so one thing to remember is this: how, looking at this graph, should we have immediately known that there were imaginary zeros or roots?
No,
It does not intersect the x-axis, right? If we're looking at x-intercepts, right, then you have real zeros. Because every number here is a real number. We don't have any imaginary there, right? So here we are, activity 6.5. This is on page, apparently I didn't write it down. That's
106.
106, thank you. So here is activity 6.5 on 106. And so we're considering each quadratic function. And it says use technology to sketch each function on the coordinate plane, label each function on your graph. Instead of doing that, because that's just going to take time, don't forget if you're at home, you always can get on desmos.com. It's a free graphing calculator, but also I will download TI Inspire software on your calculator, on your computer if you want that. I'm trying to check, see if it'll work on iPads. But here are the graphs, okay? So it is labeled for each of these. And so as this whole class, right, so I want you to take 20 seconds, think individually, and then you're going to share out your ideas. So remember, we're going to be building on each other's ideas. Number 2 says, what do the solutions of the three functions have in common? So take 20 seconds to think about what the solutions of all three functions have in common. Madison, should y'all have moved up here to the
No,
closer
no, we're
group?
okay. Oh,
Who wants to share what they have noticed? I'll start with Emma, and then I'll move around, see if people want to add on.
None of them are on the x-axis.
Okay, does anyone want to add on to that statement or push back?
Intersect the x-axis.
Okay, so none of them are on the x-axis, none of them intersect the x-axis. Gabby?
They have y-intercept.
Okay, they have y-intercepts. Anybody want to add on? Peyton?
All of them are concave up.
Okay, so all of them are concave up. I want to pause though, because I want you to think about at least 3 of these answers have used one word that has not been super precise. We want to be more clear with our language. Does anyone know what word that is? They or them. When y'all are talking about they and them, what are you referring to?
The parabolas.
The parabolas, there we go, right? The parabolas are concave up. The parabolas do not intersect the x-axis, okay? But I want you to look again at number 2 because we're missing a little bit about what the question is asking. It says, what do the solutions of the three functions have in common? I will say this, another word for that word solution is a 0 or a root. So think about that. What do you want to add on? Max?
They all have 2 zeros.
Okay, so we know, because we've studied quadratics, that they all have 2 zeros. Can you see those zeros, Madison?
hey, how does that one have a 0? The purple one,
Blue.
blue one.
That's a good question. And so why do you ask that question?
Because it doesn't look like it has a 0 from over here.
Okay, when you say it doesn't look like it has a 0, what are you looking at that means you don't think it has a 0?
That's what I'm trying to figure out.
Anybody know?
I mean, x1, right? X represent 1, right?
Maybe. Jackson?
X is squared. So
Okay.
zero.
So x is squared, so we know it has how many zeros? 2. Remember we talked about this last week, that the power or the degree, right? All quadratics are a degree 2 polynomial because the highest power is 2. So because it has a power of 2, we know it has to have 2 zeros. But what's giving some of us trouble in identifying it? Or identifying the zeros? Y'all are killing me.
Are you asking?
Yes, I'm asking you.
We can't see it or something?
Yeah, why can't you see them?
I don't know.
Because they're imaginary numbers.
Because they're imaginary roots! Oh my gosh!
I didn't know that.
It's like we're studying imaginary numbers, right?
That's crazy.
That's crazy.
We are?
Yeah, I know. Okay, so what do the solutions of the three functions all have in common? We know that there's how many solutions?
3. Or
Each equation has how many solutions? 2.
6.
It's quadratic. Well, each equation has 2.
6 total.
So 6 total, but each equation has 2, but can we see them?
No.
No! So they are imaginary. And why do we know we can't see them?
Because they're imaginary.
But how do we know they're imaginary?
They don't go through the x-axis. Because they don't intersect the x-axis.
There we go. How do we not see them? Because they do not intersect the x-axis. I think Max said that by his reaction. My bad, dude. All right, so do keep in mind, talk a little bit louder sometimes. You got good ideas, but I can't always hear
We
everybody.
need to draw those graphs.
I really don't.
I was just asking.
Here's what I would say.
I mean, no,
What's
I know
an
I-
important point that you could draw for this red one? Does anyone know?
That's orange.
That's
what
red,
is
girl.
red?
The vertex or y-intercepts.
Babe, you need your glasses.
What's that point called? Use your language. The vertex
And the one-
is 2, 1. Remember, that's vertex form. If you have vertex form, you know the vertex right away, don't you? Another good point I heard someone mention is the y-intercept. That would be good. You don't have to do that one. I think that's 0, 5. And so that means I would also have 4, 5. You only need a couple of points to sketch. You don't have to be super accurate with these graphs. You can just sketch it quickly. So the red, which is g of x, those are 2 points that I might use for g of x. Why is what? What do you mean? you just gotta remember that this doesn't have the same scale that that does. That's all it is. So, well, one thing I would do before you just start drawing a whole bunch of points, draw each parabola first. Like, I would have just drawn this g of x first before I start doing other points. But 2, 1 for g of x, draw that parabola. It's just a sketch. It doesn't have to be wicked accurate. Okay?
My chart look different.
That's on the
It has a
calculator.
different scale than what's on here. It's okay. Draw your points, sketch your graph. For this black one, which is h of x, that is 1, 1. And I might do this point. You can do a couple of them, but I'd probably do this one over here. -1, 5. And 3, 5. And then I would sketch that. 3 points like that, you can get a decent sketch going.
So we're drawing these on our thing too?
Remember, you drew that point, right? 0, 5?
Huh?
So that parabola's going, yeah. Do your best to sketch that U-shaped parabola. It's called a parabola though. Okay? And this is why I was saying that we should draw each graph, do those 3 points, and then sketch it out. Sounded like a death over there.
Come on, I didn't. You can make me mad. Mr. Kenny?
What?
You're smiling. Stop.
Sounds like you going with an attitude.
I do that because you want me.
Okay, so graph those points, graph the individual parabolas, and then sketch it out for those other values. Once you get your graphs done, make sure you get that note for number 2, that we know each function has 2 zeros or roots, but we don't see x-intercepts, so the zeros must be imaginary. Thank you for cooking that. It's just going to help. When there's a break, Tori and Peyton, if y'all can move up as well, that'd be good.
They don't have to. They're all good.
I mean, active collaboration is a part of their group
She
too.
can collaborate.
That's literally impossible.
How?
Collab.
Stop talking to yourself. I mean, that's a little.
People get put into mental asylums for stuff like that. Yes, Destiny. It's not because you hear voices in your mind. All right, sorry.
I talked to myself all the
It's a
time.
joke. I'm sorry. Huh?
Jeffrey Dahmer called me.
All right. We're getting back to quadratics. My bad for getting us off. Sorry for getting us off topic. Let's get back to it. Destiny. You need to draw your graphs and take your notes. What? You earned it. Huh? Good. All right. Hey, I'm about to move on. If you do not have your graphs done and your notes taken, you need to get those things down now. We'll get you notes from somebody else.
I smell mangoes.
Say again.
I couldn't even see for half.
Yeah, and you're still almost done.
Right.
Oh,
No. You don't have
Are you that dangerous?
You just can't see.
Can I erase the points for the graph?
Do you got it?
sure.
Or is it Leo over here?
Okay.
Probably.
That's big.
Now, Lily, you should smell
You gonna
like
be sick.
mints, like burnt.
Like Jeffrey.
Okay. Stop. Stop.
I'm sorry. finished that Salida. I finished it last night.
How much studying did you do for your math class?
I came out. Finish what? Jeffrey Dahmer.
Alright,
Why you finish it before me?
so let's look at number 3, starting on this one. So we're looking at just x squared plus 9 at this point. Describe the structure of the function. How does it compare to the function q of x equals x squared minus 9? Very, very similar. But, hey, I'm teaching. Okay. Does anyone recognize the structure of x squared minus 9? It's something we've talked about in class a couple times.
Didn't we say it was like vertex form?
It could be standard form, it could be vertex form, but this is a special case.
Isn't the difference in squares?
You talking about zero product?
Is it that AX minus B?
Hold on, let's pause for a second because I want to address something. Could we be talking about the zero products property right now?
No,
It's not equal to 0.
It's, yeah.
So 1 is not equal to 0. 2, what else do you need for zero product property?
Your factors.
You need factors. Remember, zero product property. Yes, you need a 0, but also factors. Remember, I could have a 0 here because if I'm looking for an x-intercept, what is y automatically? 0, right? So I could have a 0 there if I'm looking for an x-intercept. But the bigger thing is a difference of squares. Is it a difference?
Yes.
Yes. Subtraction. X squared. Is there a way to rewrite 9 as something squared?
3.
3 squared?
Yes.
So is that a difference of squares?
Yes.
Yes. So how could I rewrite this factor? There was a really quick way for a difference of squares. Anyone remember?
You talking about the parentheses and stuff?
Factored form, yes.
Oh, x, parentheses,
X
Hello.
minus 3.
x.
No, plus 3.
Yeah, but you gotta put the x in the front, right? Oh,
X minus
do
3.
it again.
When it's a difference of squares,
Plus and minus.
it's the x plus the 3 and x minus the 3. Remember, what is x times x?
X squared.
But when I distribute inside, I get 3x minus 3x. And what's that going to create? A 0. So when you have that difference of squares, that's why it's x squared minus 9, because those middle terms cancel out, creating a 0. Okay? So this is that difference of squares, x plus 3 times x minus 3.
What are you doing?
Huh?
Why are you erasing?
Well, because that wasn't the focus. The focus was rewriting it as a difference of squares.
So if it's a difference of squares, it's gotta be 2 squares?
It's got to be 2 things that can easily be squared.
You would define easily.
I mean, you say that, that's fair. Technically, even that could be a difference of squares, because 5 could be rewritten as the square root of 5 squared. So that would be x plus the square root of 5 times x minus the square root of 5. So anything can be rewritten as something squared, but if it's a perfect square, then it's just 3 squared. If it's not a perfect square, you just literally rewrite it as the square root of that number squared, and then you have a difference of squares there. So either way, you're right, it'll work. But is this a difference of squares?
No,
No.
that's an addition of squares.
It'd be a, so what's another word for an addition of squares?
A sum of squares?
A sum of squares, right? Notice it's a sum of squares. Very similar to the difference of squares. And I'm not going to stress about B because you can literally just see it on a graph. Remember, it's going to be imaginary roots when the graph does not what? Have x-intercepts, which is when it intersects the x-axis, right? That's when it's going to have imaginary zeros. But we're going to look here at C. What is the factored form of a sum of squares? Okay? So there is a way to get a factored form still. If I have x squared plus 9, we already know how to factor it if we have a difference of squares. Is there a way to rewrite this as so that it's x squared minus something? I want to rewrite x squared plus 9 as x squared minus something.
X squared minus negative 18.
The square root of 3?
Okay, so
Minus negative.
let's look at square root of 3.
Oh,
Is
square
that
root
the
of
same thing
9.
as x squared plus 9?
9?
What about negative 9? Would that give me x squared plus 9?
Oh.
That plus would just be
Turn square.
subtracting a negative. Does that make sense? We good with that?
Sure.
No? Anybody have a question about it? I'm getting some looks like Mr. Kenny, I'm not 100% sure yet. Okay, seems like we're okay there. After we've taken a second to look at it. Here's the thing though, is there a number that when I square it, I get -9? A number squared equals -9, because that's what I need for that difference of square.
Oh,
Well,
sure.
it's 3i, isn't it? 3i?
No, that's
So,
already-
let's pause, hold on, pause. I'm gonna look at two different things really quickly. What is 3 squared? That's 3 times 3, which is
Positive.
positive 9. If I have -3 squared,
Positive.
it still gives me a positive 9. So what did Hudson say?
3i.
Huh?
3i. So let's look at that. 3i times 3i. What's 3 times 3?
9.
And then I times I is I squared. Does anyone remember what I squared is?
-1.
I squared is literally -1. So does 3i squared give me -1?
Yeah.
Or -9?
Right now, trying to outsmart me. Like it.
Well, it's the only thing we could fill in here to get
I
plus
can never
9,
let TPN.
right? So now I have x squared minus 3i squared. So when it's a sum of squares like this, how will I now factor it?
X plus 3i and x minus 3.
You're a beast. Kid's such a beast.
So we know how to deal with a difference of squares, right? X plus 3 times x minus 3. So I just have to rewrite this so that it's subtracting a -9. And now, using imaginary numbers, I can find that. Okay? I'm going to show you two things to validate this information. Before that, though, I do want to ask, what are your questions before we continue?
Do you have to write an I like that?
No, but if you...
I mean,
No, I mean, that's a valid question. I always write it like that so that I don't mistake it with a variable or something else. If you look on the calculator really quickly, if everybody could pick up their calculator and hit the pi symbol in the bottom left. The pi symbol that's on the bottom left. So turn on the calculator, hit the pi symbol in the bottom. Well, you need to open up a calculator
It's like a
page.
bolded italic.
You
It's
said my name?
it looks like a bolded italic I, so that's why I write it like that. Say again.
Bless you.
Elation, what was your question?
Yeah.
Okay, so once the calculator is open, if you hit that pi symbol in the bottom left, you'll see an I there. So it's not the variable I, it is the number I. That is traditional, I think. Is that what you'd say as well for that, Cecil? Right. It's just what's traditional to make sure it's not a variable. Okay, so what are the solutions? Well, first off, I now have a factored form of this is equal to 0, right? I want to find those x-intercepts. What can I now use to solve this equation?
Distribution. Zero product property.
Remember, once I have it factored out, I want to use that zero product property. X plus 3i is equal to 0. X minus 3i is equal to 0.
Subtract I.
And then add over here. And so we get x equals -3i and x equals positive 3i. Those are our zeros. If you were to substitute these numbers into the equation, they would make that equation true. And I will point this out. Can you check these solutions on the graph?
Yeah, put in your graph,
Can you? What kind of numbers can you not see on the graph?
yeah.
So can you check these kinds of roots on the graph? Nope.
So how you know if it's wrong?
You would have to be able to substitute it back in. So your calculator can actually do this. If you were to substitute in 3i squared plus 9 equals 0, put that into the calculator. What does it tell you? So I would open up a calculator page and literally check that. What is
Okay, what are we typing?
3i squared plus 9? Note, you have to go to the pi symbol to get to the number I.
Alright, 6 squared.
Did you square your 3i?
3i
maybe
squared.
3 times I.
Yeah, I was gonna say, you need the parentheses around that 3i,
Plus 9.
Plus 9 equals 0. What does it say?
Mine says true.
But, no, you need there we go.
I got you.
Yeah. So if you type in that 3i squared plus 9 equals 0, it tells you that the equation is true. Huh? Remember, we were started out with the equation x squared plus 9,
Oh, I know you did.
and so I substituted into that equation
Yeah, that's right.
because I want to see if it makes the equation true.
No, I'm saying like your body right there. So, messed up together, I can't see it.
Sorry.
I look my own.
Really quickly though, I do want to point this out. Does anyone know of another way to solve this equation other than factoring?
Subtract.
Can I subtract 9? Right? If you see this vertex form, you can use what here?
Square root.
Well, what am I using?
Inverse.
Inverses. Once you have that vertex form, you can use inverses. Now,
Square root.
square root.
X equals. No, it'll be 3 and a half, right?
Wouldn't it be a 3i still?
Yeah.
Remember, that's the square root of -1 times 9. You always want to factor that -1 out. So square root of -1 times the square root of 9, which gives me 3i. I'm missing something though.
Yeah, just go negative.
Plus or minus.
Every time you take a square root, you need a plus or minus. Remember how we had a positive and a negative over here? So good memory on that, Destiny. But we want to remember, that's why I bring that detail up over and over again. We will forget, and it's okay to forget. We need to start paying attention to that detail and start to not forget. Yes, Tori?
Was that like a new way to solve the problem that you just wrote down?
A new way to solve, like here?
Yeah, what was that?
Remember, if you have vertex form, which this is a form of vertex form, you can just use inverses.
Oh.
Right? I subtracted 9 to make a 0 in property of equality. So that's not a new method. Nothing we've done, or nothing we're doing today is a new method. It's literally just building on what we've already done. Okay? What are the 3 methods to solve a quadratic equation?
Factor.
Factoring and using
Zero product.
zero product property once you factor. What else? Vertex form and using our inverses with properties of equality or
And quadratic formula.
quadratic formula. Those are the 3 methods. Those are the only 3 methods we're going to use. Okay. There is one called completing the square, which kind of ties into vertex. We're just not going to stress about it. Okay. Now, here is why we need to make sure that we understand the different forms of the quadratic equation and know roughly what the quadratic would look like. So part A says, how can you use the structure of the function to determine whether its zeros are real or imaginary? Notice we don't have a graph right now. How could we look at that equation and know if it's going to have real or imaginary zeros? I want you to take, let's say, 60 seconds to 90 seconds. Talk about it within your group. See if you can identify what is there, right? When you talk about this with your small group, that should generate ideas, meaning that some of us who haven't talked as much might be more willing to talk. Talk about what your group said. So, 60, 90 seconds, let's get to work on talking about this.
Isn't that a vertex?
So what are you talking about? What about it? Well, but the question is like, you're always going to have 2 with a quadratic. How do we know, looking at that equation, whether it's going to be real or imaginary? Why do you think that? Think about that form of the quadratic. What form of a quadratic are you looking at? Vertex form. So what things should we immediately know about this function? Well, maybe, but like think about the form. You just said it's vertex form. So what do we immediately know about that function?
So it's imaginary because of that.
So we're the same thing.
Vertex form, what do we immediately know about that function? Okay, we know the vertex. What is the vertex of this one? 2, comma 1, right? And then what else do we know immediately about every quadratic based on the equation? Whether it's vertex or standard or factored, we can immediately see the concavity. So 2 comma 1 and that parabola is concave. You're halfway there. Thank you. Thank you. So please note the question is, and again, you don't have to master this idea. We're going to have a whole class discussion to hopefully see it where you share out your ideas that you talked about in your small groups. But we're focusing on the structure of the function to determine whether its zeros are real or imaginary. What's a starting point that we might have talked about in our groups to recognize if we have real or imaginary zeros?
Figure out what kind of function it is, or whether it's what form it is.
Okay, so because I will point this out. Okay, so starting point maybe is the form, right? The form of the quadratic, because we know all of these are what type of function? Quadratic, okay? So what form are we looking at?
Vertex.
Vertex form? Can anyone build on that and tell us a little bit more that we know since this is vertex form?
We can see the vertex.
We know the vertex. What is that vertex?
2, 1.
And so this should immediately help us picture something.
The parabola.
The parabola, the vertex is in, the vertex is in which quadrant?
The second or first?
First.
Like, it goes counterclockwise, right?
Well, it starts in positives.
Oh,
And then counterclockwise. So 2, 1 would be here. That's my vertex. What else should I immediately know?
Concave up, because it's understood to be 1 for the parentheses.
You know, I just think,
So this is why we need to be familiar with those forms of the quadratic, right? It wasn't just making you learn these things. If we can picture, hey, the vertex is in quadrant 1 and it's concave up, does it have real or imaginary zeros? It would have to have imaginary zeros. Picture vertex with concavity. Okay. So, I want you to work within your small groups. I want you to take a couple minutes to work on B, figuring out what the solutions to that equation are. Huh? Oh, you went ahead and already did it, so no. Okay, so go ahead and work now with your small groups. Try to solve that quadratic. We should know at least a strategy to solve that quadratic. We should know at least one strategy to solve that quadratic. That would be a part of it, but start with that equation you have. Huh? Yeah, that'd be a part of it, but remember, you need to start with what you're looking at. What form do you have right there? So what are you going to do to solve? You can, but can you solve the quadratic standard? Is there a strategy that we can use when we have vertex form? What do we use when we have vertex form to solve?
It's like
Not when it's in vertex form.
No, that's the whole wrong thing. I know what we're using, zero product.
Zero product property is when it's factored. Hold on, Madison. You're jumping ahead thinking, remember, we factor from standard form. We use quadratic formulas from standard form. We have vertex form here. If you have vertex form,
It's not, it's so
but it's
the
already
same.
given to you, you don't have to create
It's
vertex
just because
form.
they're imaginary.
Can
There's
you
no
subtract
structure.
1 from both sides of the equation?
What's the first
So
one?
you can use what? Starts with an I.
square, x minus 2 squared equals.
N
versus
versus properties of equality.
Wait, do you want first? Like when you write down x minus 2, x minus 2. Okay, that is one way.
We're all actively working together, checking if we're already finished or almost
So she's
finished.
saying it's x minus 2 squared,
Getting
so
there.
instead of
Okay.
writing it like that, it's x minus 2
Okay, I was gonna
times
say,
x minus 2.
I would write this under here. You're fine. I didn't see you write the -1.
That's
Be
one
careful,
way.
make sure that you're writing those out first. Make sure you're also noting what's 1 minus 1.
You
zero,
can use
so you
quadratic,
want
you
to
can
note
expand
that it's gonna create a
What
zero.
about, think about when
Right.
we're
Keep that in mind, so that
I mean, one right now, we're trying to
questions, comments, concerns? Feeling
What
okay
about,
with
what
this?
about that?
Okay, make sure that you show your inverses, even here, that you're adding to. So like yeah, and here, you're just kind of writing equivalent equation, but for those fours, yeah, for the four pluses, I wanna see your inverses all the way through. So you did that with your square root, right?
Okay,
But subtracting one and adding two.
yeah,
Does that make
subtract
sense?
the 1 over.
So I was just making notes instead of doing it all the way.
No problem.
Weird.
Versus
Thank you.
all the way
Thank you,
to the square root, right?
thank you. So, what is the strategy that we want to use once we get vertex form?
The inverse operation.
Inverse operations, guys, don't make it more complicated than that. We already have vertex form. What is the form, because I know someone's going to be tempted to do this, what is the form that we should never go to because we can't solve from it? Standard. Don't ever go to standard form. We want vertex form because we can use the what? Inverses with properties of equality. So we already have the vertex form. We want to recognize that to make our job easier. I'm just going to work through this a little bit in case someone didn't finish this out. First step to solve.
Minus one for both sides.
There we go, right? We want to show that 0 that we're trying to create equals -1. And again, notice how we're getting something squared equals a negative, which was impossible until we learned about the imaginary number system. Now I'm going to
Square root both sides.
square root. I thought I heard square, but square root, create an exponent of 1, and square root here, so x minus 2 is equal to?
I.
Anybody want to add on to or push back on
Do we
that?
have to do anything with that too, or are we done? Do we do anything with the -2, or are we done?
Do we need to do anything with the -2?
I added it and got x equals I plus 2.
So,
Don't you, wait, yeah, cause.
don't I what? Hey, do I need the plus or minus here?
Oh yeah, you square rooted.
Notice 2 plus I, how many roots is that right now? It's only 1, it's only 2 plus I, that's a single number. When you have complex numbers, which include the imaginary numbers, you have 2, which is a real number, and then you have the I, which is the imaginary number. Together, it's known as a complex number. But that's only one number. You needed to do plus or minus I. Because how many roots does every quadratic have? 2. When you take a square root, you need to write down
Plus or minus.
plus or minus, okay? Keep that in mind. What are your questions before we continue? Why what? You sure? I'm fine with a good old why.
Confused, bro.
What are you confused by?
This whole thing, man, I ain't gonna lie.
Yeah, same.
I'm confused, like, how?
How what?
Oh, because
Just don't want
you
to.
need 2 roots.
Okay.
Are you having a Wednesday? Like,
Check the email I sent. I have it Tuesday morning and afternoon, Thursday morning and afternoon, because on Wednesday, the seniors are taking the ACT work keys and sophomores are taking the pre-ACT. So it's a e-learning day for y'all. Okay, number 5A. What do you think the most efficient method to determine the zeros for this quadratic might be? I want you to take, let's say, 60 seconds within your small group, strategize, and tell me after that 60 seconds what the most efficient method would be. 5A, yep. So just an efficient method to determine the zeros there.
That's
You seem to tell me that you understood that we were using inverses.
yeah, I know we're on the
Efficient method to determine the zeros.
That's it.
Oh,
We
yeah.
used inverses to solve.
No, I'm talking about the I thing. I can't do all that. But the I
What is the square root of negative 1? Literally, that's it. We have defined the number I so that I squared equals negative 1. So I is equal to the square root of negative 1. That's it.
It's not like,
Right, so you wanted to use vertex formula.
Well, because it was x minus 2 squared was equal to negative 1. So when I took the square root, x minus 2 was equal to the square root of negative 1 is literally I. We have to go plus or minus anytime we take a square root. And then I end by, I didn't. The square root of negative 1 is equal to I. It doesn't go away. The square root of negative 1 is I. So we substitute that I in. Thank you. Thank you. Thank you. Okay? So, what method do we want to use as being efficient for number 5? Vertex form might be efficient. Is there any other option? Can we use quadratic formula? We can always use the quadratic formula. You use whichever method you want. Can we use the AC method here?
Yes.
Have you checked?
Yes.
1 times 2 is equal to 2. What are factors of 2 that add up to negative 2? So negative 1 and negative 2, do those add to giving negative 2?
No, it's negative 3.
That's negative 3. So are there factors of A times C that add up to that negative 2?
No.
So the only method we cannot use is factor. Remember, we have imaginary numbers, so we can't factor on this one. Okay, so use your preferred method, either to create the vertex form or the quadratic formula. I will write both on the board as you work through it so you can check your answers and think through some things, because I do want you to see both methods, because I know some of us are struggling with creating that vertex form.
Oh, gosh.
Oh.
This is
Who is that? He over here?
You gotta make sure you know that.
It's plus or minus b, negative b. It's not always right there. No, I thought some was in parentheses. So which one we doing? We doing vertex or?
Whichever you want. But you be aware it's negative b plus or minus b squared. The square root of b squared.
So is this, are we
Oh,
still
I
on
wrote
A?
wrong.
Uh-huh.
Are we still on
I've been
A?
learning like
Yeah.
this.
No, you're on technically C right now, guys. Might be on the next page. But you can go ahead and solve it there, but it is part C that I'm having you do. We're going to talk about the discriminant in a second. I don't think it's 4. How'd you get that 4? Why'd you make that a plus 2x? Right, so negative b would be 2 divided by 2, but that doesn't make this positive. So now I get 1 squared minus 2 times 1 plus 2. Remember, you have to substitute that 1 in. That's 1 minus 2 plus 2.
This was you right.
So 1 minus 2 plus 2. Huh.
That's what it's
I don't know what it says.
What's that for?
Every single time I do quadratic formula.
Because you're putting the square root of a negative. That's why I always say don't do the square root, just do what's underneath. So you want just the negative 2 squared minus 4
Okay,
times
so that's
1
negative 1
times 2.
times 4.
Because notice you're taking the square root
Square
of
root
the
of negative 1 times the square root of 4. And so square root of negative 1 is I times square root of 4 is 2. So it's I times 2 or 2.
You can do it either way.
Not addition.
Which way should you want to do it both ways?
Right.
Or like
Use
That
right
makes
here,
sense.
or use your A for that number. So negative 2 squared, so it'd be 4 minus 8. So it's negative 4. Notice you did an A here as well. No, it's negative B, you slow down. And then it's 2 times 1, so that's 2.
Why do you stop right there on the
Just like,
So it's 2 plus or minus 4 over 2.
not 4. You need to be careful.
But you would.
It's square root of negative.
You can simplify.
Thank you.
Negative 4 to be 2I.
Thank you. Do we need a little bit more time to finish solving this one?
Yeah, a little bit.
A little bit more, okay.
Can you come here?
Did that make sense, Lita?
I'm not stopping right there. I just haven't finished
Unless
this.
you wanted to.
Y'all, I don't want to give you the final answer on anything
So
Sunday.
I divide right here, right?
You, not yet, because it's easy to square root of negative 4.
You can divide 2 from both of them.
Is that
Because
true?
it'd be like 2
2i?
over 2 plus or
Square root
minus
of 2i? See, if you're trying to not write things out, it's going to go 2i. Remember, square root of negative 4.
Last time you asked
What's
us.
the square root of...
What happened when you started with
No.
1 equals square root of 2?
Square root of negative 1 times square root of 4.
Negative 2.
And that's a 2. And square root of negative 1 is...
It's just 2 by those two.
That's the whole thing, is that the square root of negative 1 is I. Right? What's that? Well, it's just 1, so you can get it. You can divide by 1 if you want, but you don't need to.
Yeah.
How'd it go? So one thing to be aware of right here.
Did you know hand sanitizer actually?
Oh, okay, perfect. Good, glad you're aware of that. Now you can simplify from there. Can't you divide everything by 2? So like if you couldn't easily divide it, I would stop there, but because you can easily divide, I would go to Does that make sense?
It is the answer.
I got 2 hours.
So, not quite. I would start here. Negative 4 is negative 1 times 4. Right? What do we do from rewriting the square root, guys? What do we do from rewriting the square root like that? Remember, that's the whole point, is I can rewrite it like this. So then what's the square root of 4? 2, and the square root of negative 1 is 5. Right, so then this would become, that the square root of 4 is 2, the square root of negative 1 is I, and so that's where you get 2 from there. That's what we're going to talk about. We're going to talk about that in just a second. Does that make sense? The order doesn't matter. Traditionally, we write the imaginary number second. That's what we talk about that. Thank you. Thank you. Okay, so I have to ask, first off, okay, I want to point this out. If you went the vertex route, which remember you have to do that for your assessment on Friday at least once, okay? Notice how I needed my vertex, and how do we start by finding the vertex from standard form?
Negative over 2a. X equals negative.
Opposite
Divided by 2a.
Okay, so you can say opposite of b or negative b, but the bigger part is, what? How are you saying that fraction bar? Divided by.
Over.
Say it again.
Over.
Say it one more time.
One more time.
Correct yourself. Correct it.
Divided by.
Thank you. All right. The opposite of b divided by 2a. And so we get the h value of 1, right? Remember, that's just my input, though. I still need an output. So literally, I just substitute it in to the left-hand side. And I simplify it. And so